Hello dear students, welcome back to the science class. Dear students, today in this video class we are going to study the next part of this lesson, that is magnetic effect of a current and electromagnetic and electric doorbells. Okay, see what is the magnetic effect of a current here. As you all know, the magnetism, yes, the magnets will attract the iron metals, it will attract here. You know very well that is a magnetism property. And you know every magnet has two poles. It is having two poles. One is a north pole and one is a south pole. You can observe here, this is the north pole and this is the south pole. The similar poles of two magnets repel. Okay, the similar poles of the two magnets will repel, while the opposite pole, nothing but a north and south pole, will they will repel each other here. Opposite poles attract each other. Magnets come in various shapes like a bar magnet, horseshoe magnet and a cylindrical magnet. You know that what is a magnetic compass? Yes, you can observe the picture here. What is a magnetic compass? It is having a north pole, south pole, west, east, everything here. This is what we call magnetic compass we call here. It is a navigational instrument. What is this one? It is a navigational instrument, and it is why it is used? It is used to find the direction on the earth. It consists of a magnetized pointer. It is having one magnetized pointer which is free to rotate inside a glass chamber. The magnetized pointer of the compass is like a very small magnet. Why it is a compass needle deflects away? You can see the activity they have mentioned here. You have to take a magnetic compass and keep it on a wooden table. Okay, note the rest position of its needle. Now you have to bring one pole of a bar magnet towards the compass north tip. What do you observing here? We are going to observe that needle is deflected away. Nothing from from towards its left it will move. Move the bar magnets away. Let the compass needle come to rest again. Now you have to bring other pole of the bar magnets towards the compass of a north tip. Then we are going to observe here, needle is now deflected away in the other direction. So from this activity, what will come to know? It consists of one magnetized pointer and it will move according to the poles here. Do you know why the compass needle deflects away in activity 2 and 3? Because the needle is a small magnet, and when it comes in the when it will come in a middle, okay, the bar magnet, it is either attracted or repelled by the bar magnets and magnetic field. Here the activity 2 will show that the compass needle deflects only when there is a magnetic field around. It means that in activity 3, the flow of electric current through the wire produces a magnetic field around it. Further on, changing the direction of the current, the deflection of the direction of a compass also changes. Thus we can say that a current carrying wire behaves like a magnet here. This is called a magnetic effect of an electric current. The magnetic effect of electric current it was studied by Hans Christian Ørsted. Okay, he showed that electricity and magnetism are not two separate phenomena. Okay, electricity and magnetism are not a separate phenomenon here, they both are same. In fact, electricity and magnetism are related to each other and are now together referred as electromagnetism. Togetherly, see the phenomena of electricity and magnetism togetherly, they called it as electromagnetism. The magnetic effect of an electric current can also be used to produce magnets. See here, the magnetic effect of electric current, it is used as to produce magnets. You can observe in activity 4 here, and it will show the nails turns into magnets. Dear students, this is about the magnet effects on electric current. Okay, see here, electromagnetic means what? A magnet produced by the flow of electric current in a wire is called as electromagnet. What is electromagnet? It is a magnet. It is one of the magnet, and it will produce the flow of electric current in a wire. What it will do? It will produce a flow of current in a magnet. So we are calling it as electromagnet. Here electromagnets are temporary magnets. These are the temporary magnets, and they lose their magnetism the moment current stops flowing from the wire. If the current will stop, then it will stop the moving here. Okay, see here, here they have given some of the uses of electromagnets. We will see electromagnets are where it is used in devices such as the loudspeakers, television sets, fans, telephones and electric motors. And electromagnetic cranes are used to lift the magnetic materials from a garbage. Large electromagnets are used to lift heavy cargo iron containers, and it is also easy to put these containers at the desired place by putting the electric current through the electromagnetic off. Horseshoe shaped electromagnets are used to make electric doorbells. Doctors use a very small electromagnetic device to take out small magnetic materials from eyes, ears and noses. Okay, here they have given a electric doorbell. You know the electric doorbell very well, and how it works they have given here. A labeled electric circuit diagram they have given here. This is a electric doorbell. It is having a 4 parts. Horseshoe electromagnet. U-shaped electromagnetic consists of a soft iron core with a insulated copper wire wrapped around it, and it is having a armature. An armature is a soft iron bar. It is attached to the contact spring suspended from a pivot. Next it is having contact springs then contact screw also it is having, and it is having switch battery. Okay, and how it will work, you see, it is having these all the parts. Okay, one by one you see. When you pass the one on the switch, current flows. When you pass on the switch, the current flows through the electromagnetic coil. It generates a magnetic field around the coil here. In the step 2, the soft iron armature is attracted by this magnetic field. This armature hanging from the pivot moves towards the coil here. Because of this movement, the hammer strikes the gong, making a sound. Once the hammer strikes the gong, contact between the screw and armature breaks. This breaks the circuit, leaving it an open circuit. Thus, the current flow stops the coil here and no longer attracts a soft iron armature. The process repeats again. Current flows through this circuit. So, dear students, here nothing is important. You just look at this electric doorbell diagram and the circuit diagram here. Till this we have completed this chapter. I will send the question answers and you have to write it in your fair book and study. Thank you. Have a nice day. Bye.